channel. This S120-12 power supply we repaired in our last video. Today we will check its output current. For that purpose I am using 12 volt 150 watt lamp for car headlight. Its rating is 12 volt 75 watt 75 watt. It is not 75 watt, it is less than 75 watt, but we will connect as a load and we will see how we can monitor the current. In this lamp, this pin is common pin, this is one lamp, that is center, and this is second. So common pin, this one. We will connect this common to the common. In this test, we will not use series lamp. If you don't have good experience in electronics, never do this experiment, because we are dealing with live voltage. And we will use multimeter to measure the voltage and to measure the current. I will use this multimeter to measure current. For current setting, remove this lead and insert into 10 ampere jack. Set multimeter to current. It is move to ampere DC. I connected common lead to the negative output and I will connect positive lead of this multimeter to the positive output. And this multimeter we will select to measure the voltage, DC voltage, and we will connect here at positive socket. Multimeter, voltage multimeter, this lead will go to negative point. Now this multimeter is connected between positive and negative, but ampere meter, positive lead is connected to positive and negative lead is now separate. I will apply power. We have 12 volts. Now this negative lead I will connect to this lamp. We will check the current and we will see the voltage value 12.06. The same voltage 12.06. I will set here 12.06, 4 ampere current. Don't connect multimeter for a long time because its fuse may burn out. The second filament 3.7 ampere, the voltage are stable. Now we will connect both filaments, so we will operate the lamp at full condition. 7.5 ampere, 12.06, the voltage are regulated. If we have more load up to 10 ampere, we can connect here and we can check the regulation. If a power supply maintains its voltage with the rated current, that means that power supply is good. If it fails to maintain the voltage while delivering current below its rated power, that power supply is not good. I will explain that if any power supply fails to deliver the rated current, what we can do and what are the features, what are the parameters that are interconnected in the failure of current delivery. I hope this video is informative for you. If it is good, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh. Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, welcome back to my channel. MS250-12 12 volt 20.8 ampere power supply not turning on. Let's see what's wrong. If you don't have good experience in electronics, never try to repair, because here are live voltage. Always take care for the safety. I will apply power using series lamp, and we will monitor the lamp condition. It draws power, that means its input circuit is clear. DC voltage positive, negative, no voltage. If we check input voltage, 231 volts. Output, no output. Let's see what's wrong here. Always verify voltage on these capacitors. Discharge, discharge. Here it is using UC3845, H15 and B50. Pin number 5 ground in UC3845, and pin number 7 is startup pin. Now if you see voltage at pin number 7, 5 ground, and pin number 7 VCC, 8.4 volt, but no reference voltage. That means there is something wrong with this IC. If we see in microscope, there is a crack here. This line indicates that this IC is damaged. As we detected that this IC UC3845 that we removed from this power supply, there is a visible crack here. That means this IC, this chip is damaged. I don't have 3845 right now. I have 3842, 3844, 3843. I have 3845 SMD. 3844 and 45. Either it is 1844 or 1845, 2844 or 2845, 3844 or 3845. These both ICs, maximum duty cycle 48%, 0% to 48%. The difference in 3844 and 45 startup voltage, 3844 has 16 volt startup and 3844 needs 10 volt working voltage, while 3845 needs 8.4 volt startup voltage, startup threshold, and normal working voltage 7.6 volt minimum level. So we will try to adjust the voltage because we need 10 volt working voltage for 3844, and in this power supply 3845 based power supply we need 7.6 volt. We will try to figure out the circuit and we will try to adjust the voltage. Now I will use 3844 IC here. Now the LED is turned on. If we check voltage, 12.21 volt. So the IC is controlling voltage. It's good. Now we need to check voltage on VCC pin of this IC. Pin number 5 and 7. $11.42. Reference voltage 5 volt. Before this, when the IC was short circuit, at that time it was just only 7 volt and there were no reference voltage. Now I will install this power supply in casing to apply load and we will verify it. Now I used 3844 instead of 3845. What will be a small observation that this power supply will start up with slightly more delay. Why? Because 3845 starts at 8.4 volt and 3844 starts at 16 volt. So VCC capacitor will need more time to charge. Now I will connect 7.5 ampere load. First we will monitor voltage without load. .03. So that's good. 12.02. That's nice. At 7.5 ampere load, the voltage are good. So that means this power supply is now good. Now this IC is working good because it is 20 ampere power supply and I applied 7.5 ampere. Until 7.5 ampere the voltage are good. If you enjoyed this video, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh. Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, welcome back to my channel. This Delta power supply 24 volts not turning on. If we check input AC voltage, 236 volts, 236, output voltage, no output, LED not turned on, series lamp not drawing current. If you don't have good experience in electronics, never try to repair because here are live voltage. Let's open it and we will see what's wrong here. Until now I repaired 5 power supplies. In each power supply I detected that the fan is damaged. Might be this overheat condition is making problem here. Verify voltage on this capacitor. Let's move this circuit to microscope to inspect because here is visible damage. If we see this area, this is MOSFET driver section for output power. There is something wrong in this portion. I think it is water damaged. This component is damaged. This MOSFET is short circuit. Fuse open circuit. Yes, this fuse damaged. I will use 1 ampere bus fuse wire for test purpose, and then we will install the original value fuse. We have problem in DC rail. There is short circuit on this capacitor area. PFC circuit is good, but the problem in this stage. Yes, now it's good. This short circuit here was due to this MOSFET set. Both MOSFETs are damaged. 7 and 60. Ten ohm resistor good. This resistor is open circuit. This resistor damaged. This diode is also damaged. Yes, this diode is damaged. I will remove these components from this power supply. I will use these two MOSFETs. This MOSFET is good. This MOSFET is good. We will use these two MOSFETs. This transistor is also damaged. SOT89 transistor. This PNP transistor. This NPN transistor. In this power supply, this transistor is also damaged. It is giving short circuit here. Yes, this transistor is short circuit also. PNP transistor. Now if we see this line, from here this line is reaching to this point. Here is a diode. This diode is also damaged. This signal is reaching to this diode, then it is reaching to this transistor, NPN and PNP transistor. This diode is damaged. We need to verify this section. This diode is also short circuit. $30 ohm resistor is good. We need these two diodes. Let's apply power and we will check it now. Yes, it's good now. Yes, PFC circuit started. Now if you see output section, it's good. That means this power supply is now started working. Now we replace these MOSFETs, gate drive components, these two transistors for this small signal transformer, this one. If you enjoyed this video, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh. Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, welcome back to my channel. I connected this power supply to the line voltage. Input 234 volts. No output voltage. Let's see what's wrong here. If you don't have good experience in electronics, never try to repair because here are live voltage. Verify voltage on this capacitor. DC voltage, no voltage. If we see this MOSFET area, high power MOSFET area, it is water damaged power supply. We can see the condition. Fuse damaged. I will make jumper for this fuse using 1 ampere bus fuse wire. Then I will install the original value fuse. Diode mode. Black lead at positive terminal. One diode, second diode. Black lead at negative terminal. There is something wrong. One diode, one diode. Black lead at capacitor positive terminal and red lead at positive terminal of bridge rectifier. This reading is good because we are testing this diode. We can see there is short circuit on capacitor positive and negative terminal. We will check these MOSFETs. This MOSFET short circuit. This MOSFET also short circuit. I will remove these power MOSFETs. This MOSFET is short circuit, and this is also short circuit. Gate to source, source to gate, drain, all three pins are short circuit. This resistor is damaged. This diode open circuit. One diode is short circuit, one diode is open, this resistor is open. Now we can see here diode was open circuit, it was giving 4.7K, but now it is 2.59, and this side 4.7K resistor is also giving the same resistance. We will verify these diodes. This diode open circuit, and we also need to check this diode and this resistor. We need to verify 1, 2, 3 components. This diode open circuit, this diode is also not good. Yes, this diode is damaged. One diode is giving continuity in both sides and second is open. We need to check pulse transformer, driver section, Let's connect power and check its other circuit. Yes, its PFC circuit is clear. DC voltage 393.4 volt. I will take components from this similar power supply. As we verified, the PFC section is working. If PFC circuit is not starting, in that condition we will continue to its SMPS section, that is standby power. But in this condition, when its PFC section starting, that means its standby section is good. Now I need 5 IN diode quantity 2 and 1 A2 code diode. A reverse bias, a reverse bias, forward bias, forward bias. Let's apply power and then we will check it. Yes, the LED is turned on. You can see the power supply is providing output. If you enjoyed this video, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh. Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, welcome back to my channel. Delta Electronics 24 volt 12.5 ampere power supply not turning on. Let's see what's wrong here. If you don't have good experience in electronics, never try to repair. I applied line voltage using series lamp, 230 volts. Check DC voltage, no output. If we check standby voltage on connector, no standby voltage. Let's open it and we will see what's wrong here. Always take care for the safety. When we open it, always verify voltage on this capacitor. DC voltage, check voltage on this main DC capacitor. No voltage. So it is safe to work. Let's move to microscope. This area is damaged. Its PFC section is damaged. Fuse open circuit. I will connect jumper across the fuse for test purpose, and then at final step I will install the original value fuse. There is short circuit on bridge rectifier positive and negative terminal. There is short circuit on bridge rectifier positive and negative terminal, and we can see short circuit on this PFC power MOSFET. I will remove this power MOSFET. This power MOSFET is short circuit. 20 and 60 C3. Now we can see the symptom change. Now it is giving good indication between positive to negative terminal of the bridge rectifier. There are two diodes of this bridge rectifier. Black lead at positive terminal, one input terminal, second input terminal. Black lead at negative terminal, one diode, second diode, open circuit. Good indication. Red lead at negative terminal, one diode, second diode. Red lead at positive terminal, open circuit, open circuit. Red lead at positive terminal, black lead, capacitor positive terminal, one diode. Check continuity between negative terminal to negative terminal of bridge rectifier, it's good. Check resistance on capacitor, negative to positive terminal, continuity, open circuit, good indication. Now we will apply power and we will see the condition of the circuit. We will turn on without PFC. There was indication on lamp that capacitor is charging, but there is no power output, no DC voltage. Let's check its standby section. Check VCC voltage on this VCC capacitor for this chip and this chip. 2.2 volt, wrong. Here must be 11 volt. 10.5 to 11.5 volt. VCC capacitor for standby oscillator TNY276, I think. It's 2.3 volt, wrong. Check voltage on this capacitor, 325 volt. Discharge this capacitor. This chip is 54B65S. Pin number 8 is drive pin. Drive signal is reaching here. And pin 1 is ground. This is VCC pin. So there is short circuit between ground to positive. We need to remove this IC. We can see this signal. It is coming from its drive pin. When there is short circuit, and here are approximately 320 volt, when it will make short circuit from drain to source, so 330 volt will reach here and these will flow in reverse direction to the IC. There is also a damage on this circuit. PNP transistor is good. This NPN transistor, good. This diode is problematic. Yes, this diode is damaged. I will take component from this similar power supply. Many parts are removed from here. That is this diode. This diode is good. This side cathode. Yes, now there is relay sound. Check voltage on this supply, 11.3 volt. Now we can see here is output. Now its main power section is turned on. This variable resistor is also damaged. We need to replace this variable resistor. That means the circuit is good. We need to replace this variable. Now we need to work on PFC section. I will take this resistor 3.3 ohm and 30 ohm. This resistor is damaged. This 30 ohm resistor is open and this is also damaged. This diode damaged. Its ballistic diode is good. Yes, the MOSFET turned on. I will use this MOSFET. PFC controller chip which we removed, it was giving short circuit from pin number 1 to pin number 7. Pin 7 VCC, pin 1 ground. This chip is good from pin 1 to pin 7. We will use this chip. 200 ohm. So let's apply power and we will check it now. Now we need to check this area. Yes, we can see this track is damaged here. This is due to sparking of this diode in this area. We need to check this diode. This diode is good. This track is reaching here 1.8 mega. This resistor is good. This track provides voltage information, line voltage value from here to this section, and it will go to this IC. So this signal is important signal, it must be present. Let's connect power. Excellent. PFC section is drawing current. That means its booster stage has started working. DC voltage 393.8 volt. That's nice. Output voltage 24.1 volt. Nice. With bad chip, here were just only 2.2 volt, but now 10.96. Yes, it is controlling the voltage. If you enjoyed this video, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh. Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, welcome back to my channel. Why PFC circuit is used in switch mode power supply in any SMPS? I repaired this power supply in my last video, and I detected that MOSFET in PFC section and this PFC controller IC is damaged. I turned on this power supply without PFC because I detected the problem. So I am waiting for the components for this power supply. Other circuit is working now normally. I received comment from my viewer that will this power supply work without PFC? To address this question, we will discuss in this video that why we need PFC. If we see this universal power supply, it is providing 5 volt 2 ampere. If we see this power supply, it is providing 12 volt 20 ampere. Difference in this power supply and this power supply that we apply 85 volt to 265 volt. So this power supply will produce 5 volt 2 ampere with this large variation in the voltage from 85 volt AC to 265 volt. It will provide regulated output with minimum load or with maximum load. If we see this power supply, line input, EMI filter, bridge rectifier, capacitors. Here is a selector switch 110 220. If you are operating this power supply in 220 volt utility line, that time this switch will be selected at 220. If you are operating in 110 volt condition, that time we will select this switch to 110. So it is manual selection. Why we need this switch? Because we are taking approximately 250 watt output, 12 volt 20 ampere. At that time we need some regulated voltage on this line. Basically this switch makes series and parallel these capacitors. I already shared a video why this selector switch is used. You can watch that video as well. The number is displayed on the screen. Today we will see why PFC is necessary in this power supply. First we will analyze the function of power supply, and then it will become easy to understand the function of PFC. Line voltage 50 Hz or 60 Hz whatsoever. After EMI filter, these voltage are provided to bridge rectifier. We will receive positive, negative. Here were AC voltage, but now DC voltage. We receive rectified voltage here at capacitor. It is DC rail. This smoothing capacitor, that is this one, then these voltage are reaching to transformer winding. At the second end of transformer winding there is a switching device. Might be it is transistor, MOSFET, IGBT. Emitter or source are connected to ground, and there is a drive signal here. This drive signal comes from this PWM controller. It will switch. When it will switch, it will allow current in this transformer winding. In result, we will receive output voltage in the secondary. This is our output area. In SMPS, we need regulated output. A portion of the output voltage is connected to a reference regulator might be it is zener, adjustable zener. It will drive optocoupler. When the voltage will maintained at output, it will allow a switching to this LED, IRED, that is part of optocoupler. This optocoupler will provide feedback to this PWM controller. TL431 or any zener, anything that will sense the voltage. Now this is our feedback loop. When voltage are maintained here, if there is load or no load. For example, we need 5 volt. When the voltage will drop from 4.95 volts, it will give feedback. When the voltage will exceed from 5.05, it will change the variation. So this feedback will ensure the availability of the voltage at this position 5 volt. This PWM controller IC is driving this switching device at high frequency, 50 kilohertz, 60, 100. What that means? This is one switching cycle, 1 hertz. Then other cycle. This is one cycle. So this IC will provide, for example, 50 kilohertz. That means 50,000 hertz. It will turn on or turn off this switching device. When it will turn on, it will give high signal. When it will give high signal, at high pulse, this transistor will switch and it will allow to current flow in this transformer. We will receive output. When the voltage are maintained here, this feedback loop will reach to this PWM controller, and PWM controller will become to know that voltage are maintained. If the voltage will increase, what it will do? It will control the magnetic field of this transformer. How it will do that? It will reduce its duty cycle. It will turn on this transistor for little time, for shorter time. So less magnetic field will be created in the winding. We need a little amount of voltage to replenish this capacitor, because this time we are not connecting load. If the voltage will drop, this IC will become to know that voltage are dropped. It will increase its duty cycle. For each cycle, it will adjust turn on time vs turn off time. So this is regulation technique. If you connect load here, in first condition, there was no load. But if we connect load, for example, we need 5 volt 2 ampere. At that time, a little voltage drop will appear at this point. So this feedback network will sense that fall in the voltage. It will give feedback. So this IC will increase the duty cycle. One condition. If you connect 2 ampere load, there will more drop in the voltage. When there will more drop, this feedback will ask this PWM controller to increase the duty cycle, so it will turn on like this. This is on time, this is off time. So it will adjust its on time vs off time to control the current flowing in this section. So this controlled current will control the magnetic field. That controlled magnetic field will be transferred in the secondary. Secondary voltage will rectified and load regulation. It is called load regulation. When any power supply adjusts its duty cycle based on the load from no load to maximum load, it will adjust its duty cycle. It is called load regulation. If there is no load, it will provide 5 volt. If there is medium load, it will provide 5 volt. If there is maximum load, it will provide 5 volt. By adjusting duty cycle, by controlling the current. This is one condition. The second condition, if we are providing 220 volt here, rectified voltage 310 volt, DC 310 volt, at that time a small switching cycle will cause to flow more current, because we have voltage I is equal to V over R. In this condition, R is equal to XL, inductive reactance. We are flowing this current in inductor, so XL. If we say I is equal to V over R, I is equal to V over XL. Here is XL. XL, inductor value and frequency. At high voltage, we need a short amount of turn on time to create required magnetic field. But now in other condition, if these voltage are dropped here at 100 volt AC, this 100 volt AC rectified, it will become 140 volt. This 100 volt will become 140 volt. At that time, we need more switching time, more wide turn on time to provide magnetic field in this winding, to maintain the voltage here. In that condition, this PWM controller will adjust its duty cycle to regulate this 5 volt. Our basic agenda to regulate 5 volt at output stage. Either this drop is due to load or drop in line voltage. If due to load, it will adjust duty cycle. If this drop is due to this drop, line drop, it will adjust duty cycle. In both cases, line or load, if the voltage will drop at this point, it will adjust duty cycle. It will increase duty cycle to increase voltage. If the voltage are becoming high, it will decrease duty cycle to decrease voltage. That increase, maybe if we remove load, the voltage will increase. Or if there were 100 volt, suddenly the voltage are increased to 220 volt, the voltage will increase. Why? If using same switching cycle, if it is working at 140 volt, line increased, voltage increased to 310 volt, it will double the magnetic field, so there will more voltage in output. But no, this IC, this PWM controller will adjust its duty cycle. This is flyback technique. It is used for low power loads. 5 volt to 2 ampere, that means 10 watt. If you see here is a switch to compensate this variation. If we are operating this power supply at 220 volt area, at that time maybe 185 to 245 volt, this PWM controller can adjust its duty cycle and it will provide regulated output. If the voltage will drop than 185 volt, maybe this power supply will lose its line regulation, because line voltage are dropped. Why? Because we are taking 250 watt output. So in that case, this IC will fail to regulate the voltage due to line loss. For that purpose, this switch is used here. If we are operating at 110 volt, at that time line voltage will be regulated at DC rail. So we will take regulated 250 watt output. This is cheap design. If you see this delta power supply, it will receive line voltage here, rectifier, then these voltage are passed to this PFC choke, PFC inductor, then a rectifier. Here is some switching device. If you see this transistor, it is connected between positive line and ground. Either it is MOSFET, IGBT, transistor, whatsoever. It is being controlled by PFC controller. PFC controller IC will sense the voltage present at this line input voltage. It will sense the voltage here at this capacitor. It will compare these values and it will drive this PFC circuit MOSFET. It will turn on this MOSFET and it will switch here. When it will switch, it will make a short circuit on this DC rail. Voltage positive and negative here. This turn on for very short time will create a surge current in this core. So it will store energy in this inductor, then this MOSFET will turn off. When its stored magnetic field will collapse again, so its reverse EMF will become opposite in direction. Before this end was positive. In result, this end will become negative, this end will become positive. If 310 volt here, in case we are providing 220 volt, 310 plus 80 volt from here will be rectified because this diode is forward biased now. We will receive 390 volt here at this capacitor. If we check this circuit, here this PWM controller was adjusting its duty cycle with line drop or with load drop. But here this PWM controller will become free from line drop because we are providing regulated voltage at this point. That is this area. So in this design, this line variation on DC rail is finished because we will provide this 390 volt. If the voltage are dropped here until 100 volt DC, we need 390 volt here at this point. 390 minus 100, so we need 290 volt to produce 390 volt. When this line was at 220 volt, it was switching for low time like this. When the line is dropped, it will turn on this transistor for long time to store more energy in this core. That is this one. And in result, 100 volt from line and 200 volt created from this choke, this inductor, will provide resultant output at this capacitor. So we will regulate the line voltage at this capacitor. This PWM controller will just only adjust the load regulation. So the duty of this PFC controller is to compensate the line loss. If the line is varying from 85 volt to 245 volt, 260 volt, this PFC controller here will switch this MOSFET to store energy, then this energy will be rectified, by this rectifier, and we will receive voltage at this capacitor positive terminal. PFC controller will maintain 390 volt at this point. Then the next duty for this SMPS controller, PWM controller, it will switch these MOSFETs, and these MOSFETs will drive these voltage 390 volt to this transformer, and we will receive regulated output voltage. So this is the function of this PFC controller. I hope this video is informative for you. If it is good, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh. Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, welcome back to my channel. 12 volt 10 ampere power supply, 120 watt. It is not giving output power, but there is a tick 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 sound. I will apply power using series lamp, and we will monitor the lamp condition. If you don't have good experience in electronics, never try to repair, because we are dealing with live voltage. There is tick tick sound in this power supply. If we see output, there is fluctuation, low voltage fluctuation. If we check input voltage, 220 volts. Let's open it and we will see what's wrong here. Always take care for the safety. This is the condition of this power supply. 3842 IC. DC voltage. Check VCC voltage across VCC diode. There is fluctuation. 3842, pin number 5 ground, pin number 7 VCC. There is variation on VCC pin. Reference pin also varying. That means there is problem in secondary side. Verify voltage on this capacitor. It's 5.1 volt. It's okay. We need to verify this rectifier. It's good. दिस रीडिंग इज नॉट गुड। यहाँ पर ये जो रीडिंग आ रही है ये ठीक नहीं है। Yes, this Zener diode is damaged. Yes, this Zener diode is damaged. 1N4741. Yes, we can see the symptom now change. We removed this Zener diode. This capacitor gone because this time the feedback network is not working properly. Good optocoupler is giving 0.6 reading, but this one is giving 1.5. That's wrong. One volt. It is open circuit. Yes, this optocoupler is open circuit. यहाँ पर देखें ये इन सर्किट तो 1.4 वोल्ट दे रहा था, लेकिन यहाँ ये ओपन सर्किट है। इसकी जो एलईडी है वो ओपन सर्किट है, तो ये ऑप्टोकपलर हमारा ख़राब है। That means we need to check this Zener reference. 11.49. The problem was this optocoupler. It caused to damage this zener. Now if we see VCC voltage 11.8 volt, that means our power supply started regulation. Now I will connect 7.5 ampere load and we will check the voltage. Now voltage are 12.14, 12.13. The voltage are good. That means this power supply is working good. Now the voltage are 12.13, 12.10, 30 millivolt drop. That's good. If you enjoyed this video, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh. Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, welcome back to my channel. In last video number 1071, I repaired this 12 volt 10 ampere power supply and I detected this optocoupler bad, one zener diode short circuit, and while repairing we damaged this capacitor. And I received many comments from my viewers. First of all, I am thankful for everyone who is writing comments. And another thing, if my video is not good, it is your duty to dislike it. If the video is good, you can like if you want. But if the content is not original, if the content is bad, if it is misleading, it is your moral duty to dislike the video, so that this video must not be recommended to anyone. But if the video is good and you just dislike, don't write anything, that's not good. That's when I receive dislike on my video, that means the video is bad. When no one writes in the comments, that means might be this by mistake or this by due to his intentions. I don't care about that. But if the video is bad, please dislike the video. And always try to mention that this is wrong. I will welcome. First we will read the comments and then I will reply the questions. Nice to see the bad explode. Very entertaining. Yes, while repairing, I found this 680 microfarad 16 volt capacitor bad for test purpose. I did not install 680 microfarad. I installed 470 25 volt. The actual capacitor 680 microfarad 16 volt. It is for test purpose. Thank you for this good comment. Keep repairing SMPSs. This is nice to see all possible different problems. Output diode was also my first reaction. Yes, we will discuss. This comment in Czech language. Nice work. Even smoke effects today. Thank you. Yes, no problem. Original diode. Yes, we will see this diode. Without zener diode working is not any issue. Yes, this is a repeated question for zener diode. I cannot see the names. Spanish language. South America. Excellent video, thank you. From Peru. I am thankful for writing your comment. Then Ramzan Mubarak. Jazakallah khair. Jazakallah khair. Ramzan Mubarak alaykum wa alayna, inshallah. Wish you happy Ramadan. Thank you, brother. Very nice information. Thank you. 1N4148. That is not a Zener. 1N4148 is a simple signal diode. I will make a separate video for this component, no problem. Perfect. Thank you. Without Zener diode, SMPS would working properly? Yes, we will discuss in detail after optocoupler connection feedback. Yes, we will discuss now. I have one question. What does a 4147 Zener diode do? Why does it work even without it? Yes, now we will discuss. Thank you for great video. But how did you know? You should check the Zener diode. Which were symptoms? Now I will draw the circuit of secondary side and I will explain why I checked this Zener. Very nice and scary video from Mr. Hisham. Thank you, brother. Very useful to see. Check optocoupler. How come the circuit is apparently working nice and smooth without Zener? Ramadan Mubarak from Morocco. Ramadan Mubarak alaykum wa alayna inshallah. Then Mr. Khalid Ataya from Lebanon. What did you say in Urdu? He gave me some timeline in my video. Yes, when I record my videos in two languages. First I say English and then same time I narrate with Urdu language. That is for my Pakistani and Indian viewers. So sometime in the editing, some words remain in English videos, no problem. How to buy this solder machine? This solder machine, it is Weller WR3M rework station. That is not just only desolder machine. So WR3M, it's about $3,000 US. It's available with online suppliers or you can purchase from your local suppliers. Schematic diagram where we can get. You can get the sample circuit from the data sheet. Download data sheet for that IC and then you can get a sample circuit. Then the same question, why you did not put the Zener diode back? Yes, I will explain. I wish Haseeb lived in USA. Thank you, brother. I am with you. You are with me. Thank you. Most welcome, brother. How to check IC without datasheet but only multimeter? Can you explain, sir, how? Really a very difficult question to be answered. Then no TL431? Yes, no TL431. In this power supply, TL431 was safe. Then German byte. I am thankful for sending super thanks, $2.99. Thank you for your valuable support. Let's discuss this circuit. The first question, Zener diode. The second question, how I detected Zener to test. The third question, TL431. These three questions. This time we will not work in primary side, we will discuss secondary side. This is transformer secondary winding. Then winding this end is reaching this side and this side. It is MBR 2000. MBRF 2000 CT, I think. Yes, it is MBRF 2000 CT. From the same AC line, there is one component here. That is this capacitor. With this capacitor, there is a resistor, and it is connected between this point to this point. It is RC snubber for fast recovery of this rectifier. This point is reaching to 1, 2, 3 points. 1, 2, 3, 4 points. One, two, 3 points. And second side, 1, 2, 3. These three are connected to common point, this winding. These are three capacitors, 1, 2, 3 capacitors. 2200 microfarad, 25 volt. Then the fourth connection here, that is this inductor. This one. And if we see this point covered, this covered, this covered, this done, this point already done, and one line is returning back here. Here is one resistor R28. That is exactly the same point that is here. It is 820 ohm current limiting resistor that is reaching to anode pin 1 of this PC817 optocoupler. Pin number 2 is reaching to this point, that is TL431, pin number 3. Pin number 2 of TL431 is connected to ground. Coming to this point, there is class Y capacitor here. We don't need to check this capacitor. This will couple primary ground and secondary ground to remove the noises. Now this point, here is a resistor, 2.2 ohm resistor, this one, and it is connected to this fan connector. In this power supply there is no fan, and the second side of the connector is connected to this side. If we want to connect fan will be connected here. After this we have this capacitor and this capacitor, two capacitors in parallel. It is 680 microfarad, 16 volt. This damaged capacitor, 680 microfarad, 16 volt. Two capacitors in parallel. This is inductor end. From inductor there is a zener that is connected from this point and negative. Inductor, and between negative line there is a zener that is across this capacitor bank. So its number 1N4744A. Sorry, in my last video I discussed 1N4741. I'm sorry for that. It is 4744A. If you check its data sheet, 1N4744A data sheet, one N4744 15 volt zener. It is 15 volt. This is the biggest question mark here. Why 15 volt zener is here? Because when we are adjusting this power supply, it will adjust from 9 volt to 18 volt. From this positive line, if we see this component, that is this resistor, 10 kilo ohm resistor, from here 10K, with 10K there is another resistor. This is 10K, this is 2K. In series with 2K resistor there is this potentiometer. It is 102, 1 kilo ohm potentiometer. K, 1K, and 1K and 2K center point is coming to this TL431 pin number 1. And there is capacitor between pin 3 and pin 1, that is to prevent this circuit from false switching. This is primary side. It is my opinion that this optocoupler damaged, its damage is its material failure. If it is damaged due to this TL431, at that time these both components must damage. When we test it, input side IRED or LED is damaged. That means its failure is due to its internal structure, material, whatsoever. When it failed, the power supply started to fluctuate. When it started to fluctuate, it will fluctuate between 10 volts to 18 volts, and continuous fluctuation will damage this Zener diode, because here it was using 194744 15 volt Zener. It is for safety purpose, because power supply is switching above than that limit and it receives continuous strikes, that Zener may damage. So that is reason in parallel, as a parallel regulator, as a safety component, this damaged. When it damaged, it was causing tick tick sound. That is due to this transformer, because when there is short circuit here, so that is the reason. When I tested the MBR diode rectifier, it was giving continuity in both sides in circuit. Why? Because there was a short link here. If you connect in any direction, there must be a blocking voltage due to this Zener, but this Zener was damaged, so it was making short circuit. So that was the reason I removed this diode in my last video. I tested out of the circuit, it was giving good reading. Then I installed back again. After that, when it was powered on, I was touching the components. What is short circuit here? This Zener was heat up. Its temperature was increased. When any component is detected with over temperature, abnormal temperature, that is might be damaged. I detected it with over temperature condition. When I removed it, the circuit started fluctuation again. When it started fluctuation again, there are two capacitors in parallel, this one and this one. One capacitor, the same value capacitor, was weak. When it was weak, it exploded. It damaged. When it damaged, we replaced the capacitor. After replacing capacitor, still there was fluctuation. I removed this optocoupler. When removed optocoupler, the fluctuation was finished. Why? Because the feedback circuit started working normally. When it started working normally, the voltage was 12 volt. Below 15 volt, this Zener will not work. It will start working above its Zener voltage, that are 15 volt. We can say this power supply can provide maximum 15 volt. So that is the reason I did not install this Zener, because it was making short link. If this diode is present, are not present. The power supply will work with this feedback. This is an extra layer of safety. So our questions: Zener diode, why this capacitor damaged? We discussed the reason that when we removed this Zener, this PC817 was not working. The power supply started to fluctuate. That time the SMPS controller works in reboot mode from minimum duty cycle to maximum duty cycle, because that time its feedback is not reaching to IC. That time the IC will utilize maximum duty cycle, and that time that IC will reach in overload protection mode. That will cause to reboot the IC. When we fixed it, feedback network started to control the IC, 3842 IC here in this circuit. So power supply started working normally. Now if the voltage are 12 volt regulated with help of feedback network, that time if we don't install Zener, the power supply will work normal, but it is best to use Zener diode. TL431 safe? Yes, TL431 is safe because its reason of damage is material failure. If we assume overcurrent condition, I think that is impossible, because 820 ohm resistor here is reference, because most of the time PC817 is working in class B. Its CTR, current transfer ratio, is very low. It is not programmed in high current condition, so it works in safe limit, in linear conduction mode. This is my opinion. If you have any other opinion, I will request to write in the comments. If this video is informative for you, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh. Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, welcome back to my channel. This Delta Electronics 24 volt power supply is not turning on. If you don't have good experience in electronics, never try to repair, because here are live voltage. I will apply power using series lamp, and we will monitor the lamp condition. No indication on the lamp. AC voltage, (241 volt). DC voltage, no output, no standby voltage, no LED indication. Let's open it. Before touching to the circuit, verify voltage on this capacitor. No voltage. Check fuse. Fuse open circuit. For test purpose, I will use 1 ampere bus fuse wire. After that, I will install the original value fuse. diode mode, black lead at positive terminal, connect at input terminal, good, black lead at negative terminal, this is good, open, open, good, good. But if we see, there is short circuit on input terminal. Both AC lines are short circuited. The bridge rectifier is good. The bridge rectifier is good, but it is giving short circuit. That means the problem before this bridge rectifier. If I will connect series lamp, it is glowing full. And if I will check voltage on bridge rectifier, just 13 volt. If I will check AC voltage, input 10 volt just. That means there is short circuit in this area, in the primary input area. Now might be this MOV, class X capacitor, class X capacitor. These are parallel line components. Yes, if we see this MOV is separated, we need to remove MOV. Yes, now it is 1.4 mega. So this short circuit was by this MOV. This resistor is damaged. It is 14D471K. Now let's supply power. And now we will check the remaining circuit. Yes, that's nice. PFC circuit started working and power supply is now turned on. LED is on. Nice. That's excellent. The power supply started working. There was input short circuit. Now the power supply is working good. Its PFC circuit is working good. It was giving good indication. Voltage are 391.5. That's nice. So this was the problem in this power supply. If you enjoyed this video, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh. Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, welcome back to my channel. Delta Electronics 24 volt power supply not turning on. Let's see what's wrong here. If you don't have good experience in electronics, never try to repair, because here are live voltage. Always take care for the safety. Now I will apply power using series lamp, and we will monitor the lamp condition. No indication on the lamp. AC voltage. Check DC voltage. Here are no voltage. Standby voltage. No voltage. Here is burning sign. This area is burned out. Verify voltage on this capacitor. No voltage. Check fuse. Open circuit. I will make jumper for test purpose using 1 ampere bus fuse wire. And then I will install the original value fuse. Check input resistance. (1.4 mega ohms). Bridge rectifier positive and negative terminal. MOSFET short circuit. Good. Good. We can see there is some repair attempt is done on this power supply. Someone tried to repair this power supply already. Oh my god. This MOSFET is installed in opposite direction. Yes, this MOSFET is short circuit. This resistor open circuit. This resistor open circuit. This resistor open circuit. Diode short circuit. Might be its PFC controller is also damaged. First we will verify its standby section and then we will continue. $329 VCC capacitor. These voltage are down. VCC voltage down, that means this chip is damaged because this MOSFET caused to damage its gate components. These gate components take drive from pin number 8 of this IC, and this IC gets damaged very quickly. NCP1654. This track is damaged from here. This eyelet is also damaged and here is also damaged. Now I removed this IC and now we will check the voltage on VCC capacitor. Still voltage are down. That means there is something wrong. VCC capacitor. Yes, this diode is damaged. This diode damaged. I will remove diode from this power supply. Yes, this diode is good. Yes, that's nice. We have VCC voltage now. MOSFET damaged its gate drive components, that caused to damage this chip, and this chip damaged this diode. Now we will check output. That's nice. 24 volt without PFC controller, without PFC section, voltage booster section. 24 volt are now good. Now I replaced this diode and we have voltage now on this VCC capacitor. Now I will install this chip, MOSFET, and these gate drive components. This MOSFET was installed in opposite direction. Old MOSFET, the previous MOSFET, short circuit from drain to source. MOSFET damaged permanently. One diode, open circuit, touch to gate, MOSFET on. Now discharge MOSFET, diode. This MOSFET is good. Now we will install in the circuit. When we are installing, its mounting tab must be towards the chassis. This eyelet damaged from here. It is gate discharge resistor. This track must be connected to pin number 8. 30 ohm resistor at this point. 3R32 resistor at this point. B65. Its actual number is NCP1654. Let's apply power and we will check it now. Nice. Check DC voltage. 391 volt. Yes, we have 391 volt. PFC circuit booster section is working now good. Output voltage 24.01. So now this power supply started working normally. VCC 12.81. Now we will check voltage by adjusting. If you enjoyed this video, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh. Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, welcome back to my channel. Delta Electronics 24 volt power supply. When I connect to series lamp, the lamp is glowing full. That means there is input short circuit. Question. The lamp is glowing full. Fuse not opened. What is the possible reason? Or what do you think? What is the problem in this power supply? I will suggest to write your opinion right now in the comments, and don't edit or delete that comment. And then we will discuss what is the possible reason. The power supply is not turning on. AC voltage 20 volt are dropped. That means there is input short circuit. Let's check what's wrong here. If you don't have good experience in electronics, never try to repair, because we are dealing with live voltage. Here is some burning sign. Yes, this area. Check DC voltage on this capacitor. 0 volt. We can see these gate drive components are damaged. The troubleshooting technique in this case, that first we will remove short circuit and then we will verify standby section, PFC section, and then we will repair this power section. Diode mode, black lead at positive terminal of the bridge rectifier, input terminal, negative terminal. This is wrong. This reading is wrong. It must be open circuit. Short circuit on bridge rectifier terminals. This diode is looking short circuit and this MOSFET is short circuit. Yes, this diode short circuit. (20 and 60 C3 MOSFET). This MOSFET is good. So I think there was problem from this diode. I will use diode from this power supply. This diode is good. This is short circuit. Yes, this MOSFET is short circuit. Both MOSFETs are short circuit. Gate to source, gate to drain, drain to source, short circuit. This diode is good. Red lead at negative terminal, black lead at positive terminal. One diode, reverse side, it must hold the charge. That's good. .54. Now it's good. Before this it was giving one side 0.5 and second side about 1 volt. Now we removed almost short circuit. Now we will power up in this stage without PFC booster. Just only we will turn on standby section, then PFC booster, or we can try anyone. PFC booster first or power stage first. First approach, remove short circuit. Second approach, turn on its standby section. That will power up the other stages. Then we can continue to other stages, PFC booster and main power section. Now we will verify the voltage on this capacitor, DC capacitor. Yes, the lamp now returned back to normal. That means we don't have short circuit right now. DC voltage 321 volt. Now we will verify voltage on VCC capacitor. VCC voltage 9.8 volt. That means these ICs are safe now. Check voltage on this capacitor. 13.6 volt, good. 12.6 volt. 11.8 volt. Now standby section is in good working condition. Always discharge this capacitor very carefully. Now it is safe. We will install back this rectifier and MOSFET. This MOSFET is good. Good. Now I will apply power. Yes, PFC circuit has started working. $391 volt. Before this, here were 321 volt. So now PFC circuit is boosting voltage. Discharge the capacitor. This MOSFET is bad. Both MOSFETs are damaged. This MOSFET is good. This 5IN, this diode is damaged. Open circuit. Continuity. It's good. Now I will take components from this power supply. 10 ohm resistor, top side 472, 4.7K second side, and this diode here. This 10 ohm resistor is measuring 1 kilo ohm. 4.7K. This resistor is good. This resistor is damaged. We need to check this diode. This diode damaged. Yes, this diode damaged. Let's apply power. Now, relating to this MOSFET gate drive circuit, this diode is looking bad. Now we will check this diode. Yes, this diode is damaged. We also need to check this component. This diode is also damaged. This resistor is good. We need to replace these two diodes. Let's apply power and now we will check. Yes, that's nice. PFC section started working. 391 volt. Still no output. I think this pulse transformer is damaged. Yes, we can see pulse transformer is not giving reading here. Pulse transformer, this winding is open. This winding open circuit. This winding is good. This winding is good. This winding open circuit. Yes, it is disconnected from here. Yes, now it's giving continuity. Yes, now it's good. Primary. Let's check it now. Yes, now we have resistance. Before this section was open. Yes, PFC circuit started. Yes, power supply maintained 387 volt. Nice. Let's check its output. Yes, output turned on. 24 volt. Our power supply is now working good. We can see in this session for this power supply we did a detailed troubleshooting. Pulse transformer was open circuit, one winding was open circuit, these two MOSFETs short circuit, this rectifier damaged, this diode, these gate drive components for both MOSFETs. If you enjoyed this troubleshooting process, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh. Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, welcome back to my channel. Delta Electronics 24 volt power supply. I will apply power using series lamp and we will check the lamp condition. I collected power. 238 volts, but no output voltage, no indication on the lamp, no output, no standby voltage. Let's open it and we will see what is wrong here. If you don't have good experience in electronics, never try to repair because we are dealing with live voltage. Let's start. No burning sign, no smoke sign. In the first step, check DC voltage here on this capacitor. It's for safety. For DC voltage check कर ले, no voltage. Check fuse. Fuse open circuit. For test purpose, I will make jumper to the fuse by using this 1 ampere bus fuse wire. Check input resistance. 297 ohms. If we see its MOV is correct, Here its resistor is cracked. Yes, this component is short circuited. Now check input resistance. It's in 700 kilo ohms. That's good sign. Yes, PFC circuit started working. Voltage maintained at 392. Output is turned on. Now we have output 24 volts. That's good. So problem, just MOV and fuse. Now I will arrange fuse and this MOV. You can see this MOV is damaged. If you enjoyed this video, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh. Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, welcome back to my channel. Delta Electronics Thailand 24 volt power supply not turning on. I will connect power using series lamp and we will monitor the lamp condition. If you don't have good experience in electronics, never try to repair, because we are applying live voltage. Check AC voltage, 237 volt. DC output, no voltage. LED is off, and if we check standby voltage, no voltage. Let's open it and we will see what is the problem here. This area shows that might be this capacitor has something wrong. This area shows indication that there is something wrong. Verify voltage on this capacitor. DC voltage, no voltage. Yes, we can check this area. These gate drive components are looking good. I am cleaning the PCB using isopropyl alcohol. Check fuse. Fuse open circuit. For test purpose, I will connect 1 ampere bus fuse wire. When this circuit will repaired, then I will connect original value fuse 6.1 ampere. Check input resistance. 1.2 mega ohms. Good. Diode mode. Check MOSFET here. This is dry joint, so this area is heat up. So we will resolder this point. First apply power and we will check its result. PFC circuit is starting. But there is something wrong. Might be this capacitor is making problem. I need to remove this capacitor. If we see top surface of this capacitor, there is swelling here. This area is giving some crack sign. Now I will remove this capacitor to verify. I will take capacitor from this power supply. You can see its top surface is plain, while its top surface is raised upside. This one has swelling and this one is plain. Capacitor. (232 microfarad). Actual value is 270 microfarad. So it is out of limit, out of tolerance. But for test purpose I will use this capacitor. The original capacitor 211. Just for test purpose I will install this capacitor. Always take care for the polarity. Let's check it now. Yes. (394 volt). Now we can see 394 volt. This capacitor was not holding charge. I think that was the reason that this diode was becoming heat up. Now check output. 24 volt output, good. So I need to install new capacitor and fuse. The LED is now turned on. (24.16 volt). Yes. That's good. So if you enjoyed this video, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuhu, friends. Welcome back to my channel. In last video I repaired this power supply and we found this capacitor weak. It was not holding the charge. Its top surface is raised up. It has swelling here on the top surface. You can see. And it got crack here. We will study what is inside of this capacitor and what is the reason of its leakage. For that purpose, we will open it. When we will open it, first of all, it gives very bad smell. We need mask and gloves. There is some lubricant oil. If that oil will touch to the skin, sometime it will make irritation. So we will use gloves and mask. The original capacitor value 450 volt to 70 microfarad, and I replaced with a used one from a donor power supply, from a scrap power supply. Its value is also out of tolerance. So I need to use a new capacitor with good value. Let's open it. In the first step, we will check voltage. If there are voltage, we need to discharge it. For more safety, we will make a jumper to its both pins, because sometimes the capacitor terminals are disconnected, but internal plates are holding charge. If you see, its blades were punching this area. Yes, we can see the sparking sign, and we can see this area. Yes, this area of the capacitor is damaged. We can see this portion. It was making short circuit with the inner plate. One plate is this one. This is electrolyte insulator, and this is the second plate. So this insulator damaged. It was making short circuit with the other plate. This was the reason. Thanks for watching. This is the main damage area. So this shortage between positive and negative terminals, it caused to damage the fuse and other things. This PCB area is damaged. Assalamu alaikum wa rahmatullahi wa barakatuhu. Friends, welcome back to my channel. I have this Delta Electronics power supply. We will connect it to series lamp to apply power, and we will check the fault condition. Then we will troubleshoot it. If you don't have good experience in electronics, never try to repair, because we are dealing with live voltage. Always take care for the safety. No indication on the lamp. Check AC voltage. $236. No indication on LED. Check DC voltage. No DC voltage. No DC voltage. We can see there is a capacitor failure on this pad. That means this capacitor is damaged. This capacitor is heavily heat up, so it caused to make a print on this rubber mat. It is first visible damage on this board. Sometimes some indications are very prominent that give us a clear fault location by a visual inspection. In this area we can see damage sign. That is this area. This point and this point, this point. In first step, check voltage on this capacitor. If there are voltage, discharge it. So it is safe, there are no voltage. We can see this driver is also dead. This PCB area is damaged. This MOSFET gate drive components are looking good. These MOSFET gate drive components are also looking good. Other driver is also died. First I will clean it using isopropyl alcohol. If we see this capacitor, it was very close to blast. Always take care for the safety. Its insulation is melted. Let's check its failure. Yes, we can see its heat up place in this area. We can see these are the heat signs. We can see in this area its insulator is leaked. Yes, This is the main damage area. So this was the reason of failure of this capacitor. So this shortage between positive and negative terminals, it caused to damage the fuse and other things. Let's trace. Just for test purpose, I will take capacitor from other power supply and then I will install the original value capacitor. (240 microfarad). The printed value 270 microfarad. Its value is also low, but we will use because we are using for test purpose. Now I will check fuse continuity. Fuse open circuit. Just for test purpose, I will use 1 ampere bus fuse wire. It is best way to use low value fuse while repairing if there is something wrong, so this fuse will protect from more damaging. Now we will check input resistance. Input resistance of this circuit is 1.3 mega ohms. That's good. Positive terminal of the bridge rectifier, black lead. One input terminal, one diode. Second input terminal, second diode. Move black lead to negative terminal, one diode. Second diode. This is wrong. It must be open here. Red lead at negative terminal. This indication okay, this indication okay. Red lead at positive terminal. This reading is wrong. Now check positive terminal and negative terminal. There is short circuit between bridge rectifier positive and negative terminals. So this is wrong reading. Check this diode. This rectifier, it is good. Now check this rectifier. This rectifier is good. Check this power MOSFET. It is short circuit. Now if this MOSFET is damaged, then we need to check this line. It is also heat up. That means this MOSFET short circuit is caused to damage this line. This area is heat up and there are very high chances for damaging this PFC controller. N60C3 Infineon MOSFET, short circuit, drain to source, source to gate, drain to gate. All three pins are short circuited. Sparking caused to overheat this diode. 0.295. In diode mode, place black lead at positive terminal, red lead at negative terminal, one diode. Reverse the leads. Open circuit, it's good indication. Now we will install this capacitor. When we are repairing any PFC based power supply, in the first step, we need to remove short circuit. If there is any short circuit, remove that short circuit. If short circuit is finished, we will receive DC voltage based on AC voltage. AC voltage multiply with 1.414, that DC voltage must present at this capacitor. Then there is no short circuit. If any stage is not working, the first step, we need to maintain DC voltage here. If there is short circuit in any stage, in PFC section, in power stage, or in standby section, we will not receive voltage at this capacitor. If bridge rectifier is bad, if there is any short circuit here in input line, it will not allow to build voltage. Then we need to turn on this section. When it will turn on, it will sense the voltage and it will turn on this bypass relay. Here is soft starter circuit, that is surge protection for this capacitor, that this capacitor will take huge amount of current while initial charging. This thermistor will protect that current, it will limit that current. When capacitor will obtain some good voltage, at that time this relay will turn on. If this section is working good, then we can continue to next sections. Then we can monitor output and we can monitor this section. We can repair PFC section. First we will verify this PFC section, then we can focus on this section. Let's check it now. That's good. The relay is giving tick sound, click sound. That means the relay turned on. Check DC voltage on this capacitor. 327 volt. That's good. Now LED is turned on. That means this section is in good working condition. (23.7 volts). Yes, now the voltage are maintained. That means just we need to repair PFC section. Now we will use this MOSFET. Diodes, open circuit, red lead touch to gate, now channel turned on, reverse the leads, now touch black lead to gate, now one diode, reverse the leads. The MOSFET is good. This part number is BYC8X600, 8 ampere 600 volt. Because its PCB second side is damaged, there is no eyelet, so I will solder from this side. Because this track is damaged from this point, so we need to install reinforcement to this track. So in this condition, this track, this portion become weak. If you will not install reinforcement, it will damage quickly because it will not support to full current. Now it's good. Now we need to check these gate drive components. Diodes, we need to remove this diode because there is parallel resistance. This diode is good. 3.3 ohm resistor good. 30 ohm resistor good. 10k resistor good. Now I will install this diode in PCB. Now let's apply power. If it starts normally, then it's good. Otherwise we need to replace PFC controller. We can see the lamp turned on, but PFC circuit not started. DC voltage 327 volt. That means its PFC controller is damaged because we installed MOSFET, gate drive components are good, so it must take start. Discharge the capacitor. Now it's safe. First we will check continuity between this gate drive pin and pin number 8 of this NCP1654. This continuity is good. Then this diode. Good. Now we will measure VCC voltage of this IC very carefully. Ground and pin number 7. Yes, we have VCC voltage. So this PFC controller is not working. Yes, the problem PFC not starting. It is flashing now. That means this PFC controller IC is started working, but there is something wrong. यहाँ पर ये इसकी इनपुट वोल्टेज सेंस लाइन है. This is input voltage sense line. This diode is good. From positive terminal to this point, this line is good. Yes, this resistor, positive terminal is reaching at this point, but it is not reaching to this point. Due to overheat condition, this resistor is open. If we check this resistor, this resistor good, this resistor open, this resistor open, this resistor 909K good, 909K good, this resistor open, and this resistor open. This is due to this capacitor. Yes, 900K, 909K, 909K. Now I will use these two resistors. This line is good. From here to here 1 mega, 909K, 2.5. From here 2.5, that's 2 mega ohms. We are testing two resistors in series, and this end will be connected at pin number 6. That's good. So this voltage feedback, this was missing. Okay, now let's test it. Yes, that's nice. Now we can see when PFC circuit started working, this lamp flashes continuously with high repetitions. Then this lamp returned back to normal. That means the PFC circuit started boosting voltage, and now we will check voltage on this capacitor. 391.2 volt. Now PFC circuit started working, and if we check voltage now, 24.9. Excellent. So now this power supply is repaired successfully. Now we can see, due to overheating of this capacitor, these resistors damaged. Sparking here caused to damage this power MOSFET. Power MOSFET damaged this PFC controller. We replaced PFC controller, then the feedback was missing. When feedback was missing, it was not maintaining the voltage. When we replaced these resistors, and now PFC controller is working normally. We repaired this track. Now I need capacitor, power MOSFET, fuse. That's nice. DC voltage 394.6. The output is good. If you enjoyed this video, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh. Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, welcome back to my channel. Delta Electronics 24 volt power supply not turning on. If I will connect power using series lamp, it is not turning on. No indication on the lamp. If you don't have good experience in electronics, never try to repair, because we are dealing with live voltage. Always take care for the safety. 239 volts AC input. If I will check DC voltage, there is no output. If I check standby voltage, no voltage. LED off. Let's open it. Yes, here is a condition that this capacitor is problematic. We can see the capacitor overheat condition is also punched on this rubber mat. This power supply is also repaired or tried to repair by someone, because its heatsink screw is not present here. Yes, this heatsink is also removed. In this area there is also something wrong. We can see this area, that is PFC section. There is also something wrong in this area. Before working on any circuit, power supply circuit, always verify voltage on this capacitor. It is discharged, so it is safe to work. Yes, someone opened it. We can see these fingerprints. This PFC controller section might be it is damaged. These gate drive components are good. First check this fuse. The fuse is open circuit. First I will clean it. I am using isopropyl alcohol 99%. This is the heat sign of this smoothing capacitor. For troubleshooting purpose only, we will bypass this fuse. When the power supply will be repaired, then we will install the original value fuse. First I will apply power. We can see this is the condition of lamp. That PFC circuit is starting. It is flickering with low flicker rate. DC voltage 120 volt, 117 volt. So this is the problem, that this capacitor is not allowing to maintain voltage. Just for test purpose, I will use this capacitor. When this power supply will be recovered successfully, then we will use new capacitor. Discharge it, check its value. 238 microfarad. This capacitor is varying. We can see its value is changing. 102 microfarad. Value to 70 microfarad. Let's check it. चलिए अभी इसको चेक कर लेते हैं. LED now turned on. .93 volt. That's excellent. 386 volt maintained. Just only two things, this capacitor and fuse. Now I will arrange original value components and this power supply is now functional. If you enjoyed this video, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh. Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, welcome back to my channel. Delta Electronics 24 volt power supply, model number 24V300W1BA. Now we will apply power and we will monitor the fault condition and we will repair it. If you don't have good experience in electronics, now try to, because we are dealing with live voltage. No indication on the lamp. AC voltage 235 volts. LED is off. Check output DC voltage. No voltage. Let's open it and we will see what is wrong here. The circuit is looking clean. There is no sign here on the pad, but here is something wrong in this portion. That's approximately this portion. Always verify voltage on this capacitor before touching to the circuit. If there are voltage on this capacitor, discharge it. DC voltage. There are no voltage on this capacitor, so it is safe to work. This MOSFET gate driver section is looking good. EFC section is also clean. Yes, this capacitor is bludged. Check fuse. Fuse open circuit. First I will bypass the fuse using 1 ampere jumper wire for troubleshooting purpose. When this power supply will work normally, then I will install original value fuse. Check input resistance. 188 ohms. That's wrong. That means there is something wrong in this portion, because this rectifier set is good. Bridge rectifier, DC to AC input terminal, it is giving diode. That means this portion is good. Problem in the input area. First we will check this MOV. Yes, this MOV is damaged. This power supply is exposed to high voltage. We can see this MOV damaged. I will remove it now. This is damaged component. CNR 14D471K. Now let's verify input resistance again. Now it is 1.3 mega ohms. So that means the input circuit is clear now. तो इसका मतलब है कि input circuit तो clear हो चुका है. Let's apply power. Its PFC section is started working. Power supply turned on. Check output voltage 23.80. PFC section started working, 391 volt. This capacitor is bludged, but still it is working. Now I need to replace this capacitor, resistor, fuse. This power supply is now good. Now after replacing these three components, this power supply will be restored in full functional condition. One capacitor for standby section, that's this one, resistor and fuse. If you enjoyed this video, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh. Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, welcome back to my channel. This Delta Electronics 24 volt power supply is labeled as fail. Let's check it and we will repair it. If you don't have good experience in electronics, never try to repair because we are dealing with live voltage. I will apply power using series lamp and we will monitor the lamp condition. There is no indication on the lamp. Check AC input voltage 238 volts. Output LED is off. No output voltage. Let's open it and we will see what is wrong here. In last power supply, I found this bulk capacitor, and in this power supply, the same problem here. Before touching to circuit, verify voltage on this capacitor. DC voltage, no voltage. This capacitor bulged. Let's check fuse. Fuse open. Just for troubleshooting, I will use 1 ampere jumper fuse. Now check input resistance 212 ohms. In last power supply there was problem of this MOV. I think the same problem in this power supply as well. These rectifiers are good. Bridge rectifier good. Let's verify MOV. Yes, MOV is damaged. We can see condition of this MOV. MOV is protection for high voltage, any type of surge, so it protects the next circuit. If there is failure of MOV, we must install this safety. Otherwise, next time there is no chance. In last video we detected the part number CNR14D471K. Let's verify input resistance again. 1.3 mega ohms. Now input resistance is 1.2 mega ohms. That's clear. Now let's apply power and we will see the symptom of the circuit. Yes, PFC circuit started. Output LED on. Although this capacitor is bulged, it has swelling, it is damaged. But for the time being it is working. We will replace it. 23.76. It is controlling the voltage. Check voltage on this capacitor. 393.2 volt. PFC section is working good. Now I need to replace this capacitor. 400 volt capacitor, MOV and fuse. So this power supply will be restored in serviceable condition. If you enjoyed this video, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh. This power supply has something new. This capacitor is making a problem. Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, welcome back to my channel. Delta Electronics 24 volt power supply. It is labeled as fail. Let's check it and we will fix it. If you don't have good experience in electronics, never try to repair, because we are dealing with line voltage. I will apply power using series lamp and we will see the lamp condition. No indication on the lamp. Check AC input voltage. 238 volt. Check output DC voltage. LED is off and here is no output. Let's open it. Yes, this capacitor is bulged, I think. Yes, in last two power supplies the same problem. This capacitor and in this power supply same this capacitor, and here is also same problem. We can see this capacitor, its top surface is plain. So this mat is looking clean. There is no visible burning smoke or either like that. Before touching to the circuit, verify voltage on this capacitor. If there are voltage, discharge it. No voltage. PFC MOSFET gate driver components are clear, looking clean. Power stage is also looking clean, but this diode might be something wrong. Let's check fuse. Fuse open circuit. Just for test purpose I will bypass this fuse using 1 ampere fuse wire. Verify input resistance 88 ohms. This is wrong. This diode good, this diode good, bridge rectifier good. Problem in input area. In these last two power supplies, its MOV, this capacitor, fuse, this was damaged. In this power supply, MOV, capacitor, fuse, and here this capacitor, and now we will verify MOV and fuse. Yes, this MOV is also damaged. Fantastic. We have same fault in 3 power supplies. Its part number is CNR14D471K. Protection against surge voltage. We must install this safety. This is the problem. Let's check input resistance again. Yes, 1.3 mega ohms. It is high, it's good. Now let's apply power and we will see the circuit condition. We can see this power supply has something new. Maybe this standby section capacitor is making problem. Yes, this capacitor is making problem. We need to replace this capacitor. It is 2.2 microfarad 400 volt. .35 nanofarad. This capacitor is damaged. Its value is slightly high, but for test purpose I will use this one. Let's check its condition now. We can see PFC circuit started. The lamp was flashing. It was maintaining voltage on PFC section. We have 24.1 volt. We will check voltage on this capacitor. 391. PFC section is working good. Now we can see 3 power supplies in last 2 videos. In this power supply, capacitor, MOV, fuse. In last 2 power supplies, capacitor, MOV, fuses. If you enjoyed this video, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh. Standby voltage are fluctuating. We have 320 volt. That means its PFC circuit is not working. Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, welcome back to my channel. I have this Delta Electronics power supply. No output. Let's repair it. If you don't have good experience in electronics, never try to repair because we are dealing with live voltage. I will apply power using series lamp. Applied power, lamp gives indication that its input circuit is clear. AC input 232 volt. Check DC output. There is no output DC voltage. LED off. Standby voltage are fluctuating. Always take care for the safety. We can see the condition of this power supply. Verify voltage on this main DC capacitor, on this capacitor. DC voltage, no voltage. It's really very poor condition. Its PFC gate driver set is damaged. This track is damaged. This area is damaged. I am using isopropyl alcohol to clean it. Verify this power MOSFET. PFC section, power MOSFET. Its gate drive components are looking damaged. This track is damaged, but power MOSFET is looking good. Bridge rectifier output terminals 0.5. This diode. DC voltage, we have 320 volt. That means its PFC circuit is not working. Now we will check voltage for this 400 volt for standby section. These voltage are missing. Standby section is not working properly. There is something wrong in standby section. Discharge this capacitor. First we will repair this track. Replace this resistor. Check this resistor. It is showing 1.5 mega ohms. This resistor must be 10K. This MOSFET, right side pin source, center drain, black lead at drain, so it is giving one diode. It is open circuit, so it is good indication. Now touch red lead to gate, return back here. Now the channel is turned on. That means this MOSFET is good. Touch black lead to gate, one diode, open circuit. This MOSFET is good. Rectifier, good. So our main problem in standby section.